Hi, fourth graders. So the first 2 days of this week, you learned all about adding and subtracting decimals using a conversion strategy. Okay? The goal was to convert tenths to hundredths before solving. So what happens when you have thousands? Think about that for a moment. So let's begin with a little warm up to see what could possibly happen when you add and subtract decimals to the thousands. Hopefully you have a pencil and paper nearby. So grab that and let's get started. Okay, let's try these first two examples before jumping into our new goal for today. Solve by rewriting the number sentence in fraction form. Convert hundredths to thousands before solving. Pause the video to work through each problem, then come back so we can review them. Okay, let's see, how did you do? Okay. 42 hundredths minus 371 thousandths. Okay, so we have 42 hundredths. We are changing the decimals to fractions because it says rewrite the number sentence in fraction form. So 42 over 100 minus 371 thousandths. Then it says we should convert the hundreds to thousands. So we were able to convert by multiplying both the numerator and denominator by 10. You could have used the area model, or you could have used the place value model. But I decided to multiply each numerator and denominator by 10 to get the common denominator of 1,000. So therefore, 42 hundredths becomes 420 over 1,000, or 420,000, minus 371,000 equals 49 thousandths. Okay, 49 over 1,000 as a fraction, and as a decimal, 0.049. 49 thousandths. And here you see we have a decimal and fraction equivalent. Okay, so we're on the right track. B, 532 thousandths plus 18 hundredths. Okay, we have to rewrite in fraction form and then convert. So 532 over 1,000 plus 180 over 1,000. Again, this is 18 hundredths, so we had to convert the hundreds to thousands by multiplying each numerator and denominator by 10. And so 18 hundredths became 180 thousandths, which equals 712 thousandths. 712 over 1,000 in fraction form and 0.712 in decimal form, 712,000. And once again, we have a decimal and fraction equivalent. Okay, so how did you do? Awesome. So there you have it, adding and subtracting decimals through thousands. Much the same. So our new focus for today will be problem solving with decimals and being able to apply all that you've learned previously about decimal and fraction equivalency. Okay, so first you'll watch a video that will help you better understand the goal of the day, and then you'll join me for a few practice problems. I'll see you after the video.
All right, this is 4th grade Module 6, Lesson 14, and in this lesson we're going to be continuing to add our decimals, but this time we're going to be doing it in the context of measurement, liters, kilometers, etc., kilograms, and they're all going to be in the context also of word problems, and really it's just more opportunity to practice the concept of adding decimals, particularly when we convert them into fractions in order to develop that deep number sense. So let's get started.
So I'm going to mostly focus on showing how I would model the problem using tape diagrams, and then leave it up to you to solve the actual numbers, the problem. So the snowfall in year 1 was 2.03 meters, so 2 300 meters, and the snowfall in year 2 was 1.6 meters, or 1 6/10 meters. How many total meters of snow fell in years 1 and 2? So what I might do is I might do this as a separate two-bar model. And the idea is I'm going to say, well, I can see right off the bat that these two, I could see that this one is larger than this one. So I could, if I wanted to, well, no, I'm going to stick with my rule. Whenever I have two subjects, I always start with two tape diagrams that are the exact same length. Now I'm going to go back and I'm going to read the question. And it says the snowfall in year 1 was 2.03. The snowfall in year 2 was 1.6. Now, which one's bigger? Well, we know that 2.03 is supposed to be bigger, so I'm going to extend this a little bit. And I know that this is 2.03. And then I'm going to read, and it says the snowfall in year 2, right here, was 1.6. So there's our 1.6. And then the question is, how many total meters of snow fell in years 1 and 2? So that's going to be this right here. So what are we going to do? We're going to add 2.03 plus 1.6. And that's where we're going to convert this, well, into a fraction, this into a fraction, get our common denominators, and run with it. Now here, a deli sliced 22.6 kilograms of roast beef 1 week and 13.54 kilograms the next week. How many total kilograms of roast beef did they slice in the 2 weeks? So you've got week 1, you've got week 2, and I'm going to make both tapes the exact same length. And then I'm going to go back and I'm going to read the question again. It says they sliced 22.6 in week 1, 13.54 in week 2. And so I know that week 1 is supposed to be longer, a longer tape than week 2. And so let's just do that. Let's extend it a little bit. It doesn't matter exactly how much we extend it. And that is our 22.6. And then we know that this is our 13.54. And then the question is, how many total kilograms? So there's the key. How many total kilograms did they do in the 2 weeks? So that's this thing, the total amount. So what are we going to do? We're going to add 22.6 plus 13.54. Now here's a tricky one. To be honest, it took me a couple of times to read this to get it. So it says the school cafeteria served 125.6 liters of milk on Monday. That's a lot of milk. And 5.34 more liters of milk on Tuesday than on Monday. That's the key phrase right there. How many total liters of milk were served on both Monday and Tuesday? So our two characters, Monday and Tuesday, and I'm going to make those two tape diagrams exactly the same length. And then I'm going to go back and I'm going to read the question. It says the school cafeteria served 125.6 liters of milk on Monday and more milk on Tuesday. So the idea is Monday is right here, and that's 125.6 liters. Now Tuesday, it says they did those 125.6 liters, but plus they did an extra 5.34 liters because it says they did 5.34 more liters of milk on Tuesday than on Monday. So they're tied, and then Tuesday did 5.34 more liters. And then the question is, how much did they do all together? So that's the big question. Couple of ways we could do it. We could add Tuesday together first, and first add 125.6 plus 5.34, get that answer, and then add it to another 125.6. Another way we could think of it is one big long problem, 125.6, that's Monday, plus, and then we can put in parentheses 125.6 plus 5.34 on Tuesday. So a couple of ways you could think of it as a two-step problem. First, add these two numbers together to get Tuesday, and then add that to get Monday. Or you could think of it as a one-step, but secretly it's the same thing, as one big old huge equation. So here we've got Max, Maria, and Armin, and they are in a relay race. They're a team. And Max ran his part in 17.3 seconds. Maria was 0.7 seconds slower than Max, and Armin was 1.5 seconds slower than Maria. And then the question is, what's the total time for our team? So this time we have three characters. We have Max, we have Maria, and we have Armin. And again, I'm going to make all three of their tape diagrams the exact same length, the best I can. 1, 2, 3. So they have the exact same tape diagrams. And then I'm going to go back and I'm going to read the question again. Okay, it says, okay, they're on a relay race team. So that first question doesn't really help much. I mean, that first sentence doesn't add much to it. Then it says, Max ran his part in 17.3 seconds. So this length right here is 17.3. And then it says Maria was 0.7 seconds slower than Max. So what does that mean? Well, that means Maria's portion, we have to chop off. No, slower. So that doesn't mean we're going to chop off. That means we need to add on an extra 0.7 seconds. Because Max was this length, Maria took a little bit longer. And then Armin was 1.5 seconds slower than Maria. So Armin, he has to add not only the 0.7, but he also has to add an additional 1.5 seconds. So now the question is, what is the total time? So the idea is, what is the entire total time? So what are we going to do? Well, we know that we have this piece is 1.73. That means this piece right here is also 17.3. And this piece is also 17.3. So if we need to know the total time, that means we're going to have to find some way, and parents and teachers, I'm going to leave it up to you, but for our students to add 17.3 plus another 17.3 plus another 17.3, that takes care of all of these, plus a 0.7 plus another 0.7, that takes care of these, plus a 1.5, and that takes care of this guy right here. So we have to add up 1, 2, 3, 4, 5, 6. 6 decimals in order to get our total time. And that wraps up a fun one, is focusing on word problems, which means we needed to draw a bunch of tape diagrams in order for us to practice adding our decimals in decimal form. So that's 4th grade, Module 6, Lesson 14.
Welcome back. So let's begin by trying a few practice problems. Here's where you'll probably need more paper and a pencil. Okay. Problem number 1. Barrel A contains 2 7/10 liters of water. Barrel B contains 3 9/100 liters of water. Together, how much water do the 2 barrels contain? Okay. Think about it for a moment. Press pause to allow yourself some think time, and then press play to review the answer. Okay, take a look at the answer for just a moment. What I would like for you to do is just look at all the work that's involved in solving this problem. Now look at your paper. Okay? Do you have much of the same? Were you able to identify key things that we may need from the problem to help us solve? Did you use a tape diagram to solve? Okay. Did you apply your learning by converting tens to hundreds? Okay, let's check it out. Okay, barrel A, okay, here's the tape diagram for barrel A, is 2 7/10. Barrel B, okay, barrel B, we started with the same length, but we know that barrel B's tape diagram is going to be a little longer, okay, because it's 3 9/100 of a liter. So our question is, together, how much water do the two barrels contain? So we know together, we have to kind of join them. We're putting it together to see how much both of the barrels contain, okay? So once again, to apply our learning, we want to convert our tenths to hundreds by multiplying both the numerator and denominator by 10. So that's 2 70/100 plus 3 9/100, which equals 5 79/100, or as a decimal, 5.79. Okay, 5 79/100. And here you see a fraction and decimal equivalents. So we are on the right track. Okay, let's try another. Mrs. Smith had a chain 75 6/10 centimeters long. She wanted to use most of the chain to hang a planter on her porch. When she completed her project, she had 3 2/10 centimeters of chain left. Okay. How many centimeters of chain did she use for her project? Okay, so this one is a little more involved than the first one, but that's okay. Again, strategies. Let's pull out what we need. What is the important, or what are the important facts or information, clues, actions that we're going to need to help us solve this problem? Okay, then build it. Okay, draw your picture. What would it look like? Create your tape diagram, and then begin to apply your learning to help you solve. Okay. Once again, Mrs. Smith had a chain 75 6/10 centimeters long. She wanted to use most of the chain to hang a planter on her porch. When she completed her project, she had 3 2/10 centimeters of chain left. How many centimeters of chain did she use for her project? Okay. Take a few moments, work through that. You can do it. And when you're ready for the answer, press play. Okay. Once again, take a look at all of the work here. Were you able to come up with 72 4/10 centimeters? Okay. Let's work through it. Okay. We know we're looking for how many centimeters of chain did she use for her project. So what you see here is the 75 6/10 centimeter. This is what we're starting with. This is how much Miss Smith had, okay? She wanted to use most of it to hang a planter on her porch. We know that, okay? When she completed it, when it was all done, she had 3 2 centimeters of chain left. So here you see the 3 2, or 3 2/10 centimeters left. So that means we're looking for this. We're looking for how many centimeters of chain did she use for the project, okay? So once again, this is what she has all together. Here's what she has have left. It's almost like I have the whole, I have one part. The goal is to find the missing part, okay? So what is the missing part? Well, we can subtract to find our missing part. So to do some conversion, 75 6/10 minus 3 2/10, meaning we're going to take 75 6/10 as a decimal and change it to a fraction. Okay, we're going to do its equivalent. 75 and 6/10 minus 3 and 2/10. Oh, we have common denominators, so no need to do conversions, okay, to find common denominators because we already have common denominators. Okay, so 75 and 6/10 minus 3 and 2/10 equals 72 and 4/10. So we're on the right track if you were able to get 72 and 4/10. If not, that's okay. Go back and pick it apart and try it again. Okay. You'll also have some additional practice problems once we're done with our lesson for today. Okay, and you can try those on your own. All righty, let's try one more. We're going to increase the rigor just a little bit more. Okay, here goes. Are you ready? All right. Joe has a summer job mowing lawns for his neighbors. He is saving the money he earns to buy a new bike. Joe earned $45.50 on Monday mowing lawns. On Tuesday, he earned $35.75, and on Wednesday, he earned $25.25. He needs $167.99 to buy the bike he wants. How much more money does Joe need to earn in order to buy the bike? What do you think? As always, press pause to allow yourself some work time, some think time, and then press play when you're ready to review the answer. Whoa, look at all of this work. Okay, we started by highlighting and pulling out that important information, the key actions, things that was important in order to solve this problem. Okay. Next, we built our tape diagram to include all of the information that we highlighted from the problem. So we started with $167.99, okay? Because that's how much he needs to buy the new bike he wants. Then we began to partition our tape diagram to match what's going on in the problem. So on Monday, he earned $45.50. Okay. On Tuesday, he earned $35.75. And on Wednesday, he earned $25.25. And here we have a missing part. So the goal is to find out how much more money does Joe need to earn in order to buy the new bike. Ooh, okay, so in this sense, we can, here's just one possible way to solve it. You may have come up with a different strategy, and that's okay, as long as when it was done, your total was $61.49. Okay, so we can start by converting all of the, or changing all of the decimals to fractions. So that's 45 and 50 hundredths plus 35 and 75 hundredths plus 25 and 25 hundredths equals 105 150 hundredths. Okay, and then we can decompose to pull out a whole. You know, we can rename this, pull out a whole, and then we have 50 hundredths left. So we can add this whole to the 105 we already have, and that gave us 106 50 hundredths. Okay, but we're not done because that's just Monday, Tuesday, and Wednesday. We're still trying to figure out how much more does he need. So this is a two-part problem. If you stopped here, we're not quite finished. You still have more work to do. Okay, so now we can take our total. He needs $167.99 or 167.99 hundredths, okay, and subtract it from what he already had, the 106 50 hundredths. Okay, so once again, this is the total for the bike, and this amount represents what he has already, what he has collected already. Okay, that gives us a difference of 61 and 49 hundredths, or $61.49. How did you do on that? Yeah, this one was a little more challenging. It was a multi-step problem, but that's okay. Just long as you were able to pull out key information and build it, and then apply all of the learning with fraction and decimal equivalents, then you're on the right track, okay? We can keep working at it to make sure if you didn't get the correct answer, that's okay. We can keep working on it, okay? So that next time we're able to solve correctly. And that brings us to the end of today's lesson. Our I can statement for today was, I can solve word problems in decimal form. How did you do with that? Okay, yeah, so I know it was a little more than just lining up the decimals and solving. It really was about understanding place value and getting you to see the meaning behind numbers. And so that's what it was all about. Please join me tomorrow for our performance task day. Take care.